Who in here is a senior? We need a senior to call on. Yes? Oh, why do you guys look so hesitant to?
He's a senior, he's not raising his hand.
Oh my gosh, you guys, I'm not like trying to pick on you. Okay, next year, what do you assume is gonna happen on a test date for any one of your college classes? Your teachers tell you the test dates at the beginning of the marking period, and that's when they give the tests. So if you don't take the test at that point, what do you get?
0.
Yeah. And I don't get why you guys are in the mindset, 1/4 of this class was gone. If you are going to be gone for a test, you figure it out ahead of time. You don't just like ditch class and then come back and talk about it. Be like, oh yeah, I forgot I had something, when 50% of the time it's not that. You have to bring an actual doctor's note if you miss a test in college. Otherwise, they just give you a 0. They don't care, they're not gonna sit there and give a whole bunch of test dates, they're not gonna go out of their way to do this. Like, it's so confusing to me how all of a sudden it's like turning into everybody just like randomly deciding that they're gonna do tests at their own schedule. I've got way too many to correct for me to keep in mind and try to figure out when to give everybody individual tests. So it just doesn't work that way. And I just need you guys to understand, once you start paying for school, they don't care if you're there for the test or not. They just grade your test if you take it, they don't if you don't. And it's a much bigger deal, and I think far too many people are gonna find out the wrong way or the hard way, that they don't care about your test dates. Like, they'll tell you when they're gonna be. Yeah? Oh, that may work for that. Oh, it did? I was gonna say, that's usually too fixing. Okay, so unit 7. To start off with, it sounds like it's gonna be difficult. Differential equations is just a generic term that refers to derivatives. I don't necessarily even know why this section is specifically labeled differential equations, other than all of the problems deal with derivatives. But we're going to use integrals to find answers. So it's called differential equations just because we deal with derivatives. I saw a few people already turned in the work for this section. Is that only because this section felt easy enough, I'm hoping? I don't know. There's like 4 people that turned it in. Like, did you?
I just don't have time to do it any other time this week, so I just watched the video yesterday.
Oh, yeah, and I don't have a problem with you doing that. I was wondering if it was because you guys were worried about the due date or something, I don't know.
Yeah, I just.
Yeah, the due date isn't actually yesterday. I'm not worried about the due date. But if you are in the situation, that's why I wanted to give you guys all those videos, all the access to the resources. 7 is by far the easiest one that is doable not being in class. Because we've had some sections that, you know, not hearing it explained to you individually is crazy hard. This unit isn't gonna feel like that. It feels like it should be, but it's not.
So why aren't you done this?
Why wasn't that what? Oh, you make it sound like I had a choice when I got that surgery. No, the surgeon just tells you when you get to have it. He gave me 2 dates. He gave me March, whatever that was, 2nd or something, I don't know. Or end of April, which is right before the AP test. And I knew for your guys' sake, being gone the week and a half before the AP test would be bad. So I thought that would be much better choice. Yeah, doctors don't usually give you, they don't have open schedules. Okay, so the beginning of this is just re-familiarizing you with related rates, but we're not actually like specifically using them. It's just getting you used to the way things are written, way things are set up. So, Alex and Tina have a Maine Coon named King Robert. Robert is gaining weight W at a rate that is inversely proportional to his age, t in months. So there's basically just a couple keywords here. The inversely and the directly proportional, those are probably, I think, did you guys do that in pre-calc? I can't remember if you do or not anymore. If you did, it would have been right about the same time as radioactive dating. I know you do it in Algebra 2 for sure. I just couldn't remember if it's still in the pre-calc book. Semi seem familiar at all? Maybe, hopefully? No, all right, it's fine. It's easy enough that we'll be able to do it. But the one I'm more focused on is the word rate. Did I choose anybody in here to start every day with? I don't have a bingo roller because Key Club took it for bingo next week. Who should we start? Cullen. We'll have you start every day. So some days that means you answer, most days that you're just gonna choose the first person.
Okay.
It doesn't mean answer every day. We'll have you answer today. Do you remember what the word rate stood for forever ago? Seeing that word in a sentence specifically tells us something.
Like, change,
Sure.
like that.
Celt word though. I mean, change is correct, but what would be the Celt word?
Rate that it's changing. Oh my gosh.
Still correct. Does anybody know what I'm trying to ask? Derivative. Yeah, the word rate, the word change is derivative. Derivative is how fast something changes. So if you see this word in a sentence, it is referring to the derivative. So this is saying, write the derivative of W. So dW. And then the other variable is told you over there, time. So this would be how you write the derivative of weight. That's the rate. Does anybody here remember what inversely means? It's been forever since you did it, I guess. If you ever see the word inversely, that means divided by. So inversely proportional means that you are going to divide by the time. Leave a space though.
Space before.
Correct. Any equations that are proportional, we don't know how they're proportional, and so they usually have something called the constant of proportion. Maybe, so say we have somebody go sprinting down the hall and measure their speed, right? You might have somebody else in this class that is twice as fast. That would be a word for proportional, twice as fast. But somebody else in this class might be 1.5 times as fast, or twice as slow. The proportionality, that's what the K is you don't know how they're proportional yet. We just know that it's inversely because the older an animal gets, or a person, they stop gaining weight, right? For the most part, I mean, obviously not like completely, but you gain weight really fast when you're a child, and then as you turn into adult, you basically just stay that same shape for the most part for quite a long time. So that's why it's inversely. It's gain weight a lot when you're a child, gain weight very little, high school. This is the differential equation. It is a derivative equation. And these are, I don't want to call them super easy, because maybe you forgot some of the wording. No? Yes?
So what if you didn't say is it inversely, is it directly proportional or something? Would it just be like KT?
Correct.
Oh.
Yeah, that's like the next one.
Oh.
So there is really only two that you can have: directly, which is multiply, inversely, which is divide. And apparently you didn't want to get sued by Starbucks. Your cup of Starbucks peppermint coffee is cooling at a rate that is proportional to the difference between the room temperature TR and the current temperature T of the coffee.
I probably
All right, so I see cooling at a rate. At it feels weird that those are the only two variables, but, so we're gonna have the change in temperature, so the change in the current temperature, which apparently we are, I would think this has to be compared to time though, even though it doesn't say the word time in the problem. Because the amount of time that something is cooling is what determines its temperature. If I give you guys a question on a test, I will make sure I would not leave a variable to be like inferred or implied. So it would be something more similar to A, where it would have to be told in the problem. But it has to be time as well, because this is Newton's law of cooling, which is sort of in this unit. So the change in current temperature compared to time is proportional. So that K is going to be in all of these, no matter what comes after that. K is something we can figure out. Proportional is going to be the same wording as directly, so that is multiply. The difference between the two temperatures means you're going to subtract them. And I don't know if the order even matters or not. If I remember correctly from Newton's law of cooling, I think it doesn't matter the order you write them, you still get the same answer. But the way this one's written, TR would go first. I feel like A is definitely a much more straightforward example. If I give you guys one on a test, which I don't even know if I will or not, it would definitely be something where I give you all the information. Oh, where is that? Is it on the next page? This is just showing you different ways of writing derivatives. This isn't actually telling you anything at all. You're not going to have to know Leibniz notation. You probably already know function notation because you're used to it. That doesn't, it's not really a thing. Differential equation just means it involves a derivative. All three of these are differential equations. Where was the one that said general solution, particular solution? I thought that was at the bottom of the first page. It's the bottom of the second page? Oh, okay. Perfect. I wanted to make sure we weren't gonna miss that part. These are the questions that are usually the most confusing to students, only because the directions don't feel like they are super specific. They kind of just say that, show that both of these are solutions to this differential equation. First thing you should know is you will have to be given the differential equation for these problems. There is nothing you're going to have to come up with on your own for these. There are different problems at the bottom of the page that it says find the solution. That's the ones where you actually have to come up with differential equations, etc. These are ones where they want you to verify or check. Do you guys know the difference between verify and check? If this said verify something is a solution, what do you know about it? Yeah, that it already is a solution, you're just showing that it's true. Like verify means it does work. If it says check, that would mean you're finding out if it works. So there definitely are different types of questions on them. Okay, so we're just gonna pick one of these two. And what your goal is to put this equation into the differential one to see if what the information that is there checks. So we've got y double prime plus 3y prime equals 4y. Currently, the only thing we can substitute is y. So we can put 2ex in place of y. This particular derivative equation has first derivative and second derivative in it, which means we're gonna have to find first and second to be able to even check if it works. First derivative would be 2e to the x. Second derivative, 2e to the x. Like, it feels wrong to just write the same thing, but a multiplier just goes with each derivative, and then the derivative of e to the x is e to the x. So we're gonna say 2e to the x plus 3 times 2e to the x. Does that equal 4 times 2e to the x? And yes, so 2 plus 6 would be 8ex. 8ex. There's all sorts of different ways you can write the notation. What I usually do if it works is I put a check mark. If it doesn't work, I put a line through the equal sign. But there's tons of ways to write it. All this did was we showed that that is a solution, because it makes it work. And that would be the exact same thing. Find the first derivative, find the second derivative, put them in, see if it works. I don't feel like we need to do both because they're the exact same process. Those are nice and easy to get though, because you'll be given all that info.
What's the derivative of e to the
Derivative of e to the negative 4x. So the derivative of e to the u is e to the u times u prime. So it would be e to the negative 4x times negative 4. Do you want to take the time to try one of these on your own? Might as well? Oh, okay. Why don't you guys try A? Just see if you can get it to work. Or no, maybe we should do B. B looks harder. Do B. Because if you can do a harder one on your own, you can do the easier ones on your own. So the differential equation is the one with the derivative in the equation. So in this one, the top one. Have you run into the part where you get confused yet? On anything? My guess is the most confusing thing about this would be the y. And that's because they're switching between function notation and non-function notation. Y would be the same thing as g of x. Usually on the AP test, they will not give you a question where they go between notations. But this question has both types. Yeah, no, that's right, isn't it?
Yeah, that's good.
Oh. I was gonna say something felt wrong. They are close, but they are not, this would not be a solution. So they're not equal to each other. Did I do the math right? Okay. Usually they're gonna end up relatively close, because they're not gonna give you one that's, like, obviously not a solution. So like on this one, if they gave you something about like e to the x, you would know immediately that it's not a solution because it doesn't even remotely match the left-hand side. Okay, most of the work in this section is pretty much the question down here. It says for the differential equation dy dx equals 3x squared, find a general solution. Now, this is leading a little bit to tomorrow's section, because they're kind of the same thing. We're used to seeing dy dx as the notation for derivative, and it's not wrong, but it does work like a fraction. So if you multiply both sides by dx, we could have it say dy equals 3x squared dx. And this is what tomorrow's section is going to be called, is they call this separation of variables. No, wait, how do you spell separate? Is it A or E? Sep A rate? I don't know, the more I say that, the worse it's sounding in my head. Now, the great thing is that I'm not teaching you grammar, so we're okay.
Where is it?
Is it A? Okay, good. I was gonna say, I feel like separate is one of those words I always write down, and then Microsoft Word always highlights for me. Okay, so it's semi-obvious why it's called separation of variables. It's basically because you're moving letters around to group them with like letters. So there was a 3x squared on the right, so if I multiply both sides by dx, now I have all of the x's together, I have all of the y's together. There's nothing else written with the dy, but technically, it's 1. I mean, like, you're not gonna write 1 there, but that's there. And the reason I bring this up, the goal for this question is to find a general solution. A general solution is going to be something that has plus c. I believe we talked about that on the last unit, like right before we went to spring break. So a general solution will have a plus c in it. A particular solution is you figure out the c. If you are asked for a general solution, the only way to find that is by integrating. So we are going to integrate both sides of this equation to find a general solution. This is partially why the next section is going to go pretty easy for you, is because we're already doing it in this section. It's just not specifically called anything yet. We're going to talk about the name next section. Okay, so if I integrate 1, I would get 1, 1. And it's going to be a y because that's the letter we're using. If this was a dx, then we would write 1x. I can write plus c, but I don't need to. So whenever you're integrating, you only have to write plus c one time somewhere. It doesn't matter where you write plus c. We could write it right here, but nobody usually does. The plus c just has to be written once. Integrate 3x squared dx, we're going to get x cubed And then we'll just put the plus C over here, but it counts as both. And then this would be the general solution, because it's already solved for Y. The instructions are traditionally where more people get confused than the actual question. So, I mean, like, and fair enough, like, if you read through that, it feels like it's going to be a very difficult question. To find a general solution, you're always just gonna integrate because you have to get a plus C. And that's the only way we get plus C's is by integrating. And I think the next page was, I was kind of iffy on this, I didn't really care if we did it or not, but I did want to point out that the next page after this, so the page right after this, isn't it the one with the graph with tons of lines? Yeah, so that's gonna be called a slope field, and we are gonna flat ignore that for right now, because that is a separate section in Unit 7. I don't know why it's included in this section. My guess is you've never seen graphs like that before, and in fairness, you really shouldn't have needed to. So slope fields, I'm definitely gonna hold off until we get to that section, and any question in this homework, which I think there's a couple, there's a slope field on it, you can just skip that. I'm not sure why Jean like threw it in. I know she likes to introduce some topics ahead of time so that you get used to them, but slope fields is like completely separate on its own. I don't know. I kind of felt like our time would be better used with you guys trying questions here in class so that I could help you with them. Then we'll get done, 24? Oh, we only have 15 minutes left? Oh, that's tomorrow, yeah, then I'll do that. The word problem, it's not like it's terrible, it just takes forever because there's like 6 parts to it. And the only thing, there's nothing new in the word problem. It gives you some tables, which we've done with before, like you've had to find slopes from tables, you've had to find areas from tables, like there's nothing really new in the word problem other than it's just got a lot of the problems together. And it's good to do it. Maybe if we have extra time, like if I feel like tomorrow's notes is gonna go super fast, that I can come back and do this one with you. But our goal, 3 of the days this week are shortened. I don't know if you guys knew that. Tuesday, Wednesday, and Thursday are all R&R schedule. I actually had no idea Wednesday was until somebody told me first off. It's an R&R schedule on Wednesday because they're doing the Pep Fest for Unified. Yeah, I knew that was the Polar Plunge, but I couldn't remember what it was for. Unified sounds right, yeah. So it's like a Pep Fest-ish thing Wednesday at the end of the day instead of R&R. So we're gonna have 3 shortened classes and then a full class on Friday again. So time-wise, I wanted to at least leave a little bit of time so I could help you with some questions. Even if you're somebody who already went through and did the homework at 7-1, I can certainly go over questions you got stuck on, whatever it is. I think you're gonna find this homework is not terrible. Like there's a handful of questions on just writing the equation from the words, like we started with today. Let's just not overcomplicate it. Try the questions, see if you get stuck on something, and then I can help you with it.
Is this due tonight?
No. I don't know, should I just make all of 7 due Sunday? I think it's currently 7-3 and 7-4 on Sunday, but I guess I'm fine with just making all 4 of them due Sunday. I'm okay with you guys having your own pace and schedule, you just don't wanna like put it way off, and some of you absolutely do if there's no heat in it. Okay, maybe I'll change that right now, so I don't forget. I think everything else is in Schoology already, though.